So here's an example.
Hi, welcome to Stop for Science.
We're here at Section School in Mukwonago, Wisconsin.
And we're going to find the velocity of our pitches.
This is one of the classroom activities that Pat's going to explain to you. It has to do with figuring out the speed at which the students can pitch a ball. Obviously, it has to do with how fast is fast, and that particular speed you can capture by taking video of it. So if you want to go ahead and explain how.
Right, so this is one of the suggested activities for the How Fast is Fast poster. And it works as follows. It is based on the concept that's explained in the poster that speed is measured as distance over time. And in fact, Bob is the one who filmed this. We get students who pitch a baseball, and we measure how fast that baseball is going in the following way. He needs to know the distance. Well, we can measure the distance from where the pitcher is to where home plate is. Did I miss something here? In this particular example, it's about 30 feet from the pitcher's mound to the home plate, and you can look at about where this pitcher is releasing the ball as perhaps 2 feet ahead of the mark. And so actually, if I remember correctly, it was 32 feet to the pitcher's mound, and so we're estimating that it's about 30 feet that the ball travels. So all you need to do is watch a student throw a ball and sit there with your little stopwatch or a timer and go, start, stop, and measure it. And that'll obviously be incredibly accurate, and then you'll get the answer. In reality, no, it's not true because it goes pretty darn fast. Let me show you. Okay, so here's the pitcher. Imagine yourself with a stopwatch, okay? It's pretty fast. So what you can do, though, is take your video camera, film this, put it into your favorite viewing program. This is being displayed in QuickTime. And then pause it and step through and watch the pitch. So look at this is really, by the way, this kid's got an amazing form. It's true, look at that. Yes. But the ball is obviously leaving his hand right here, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 is right when it's crossing the plate. 12 steps in the movie, right? And so all you need to know is how long each one of those steps is. But you see, or you might be able to see, that right down here in the corner, there's a little thing that counts out how many seconds long the video is running. So if we just go to when it is changing from 1 to 2 here, right? And now we count how many steps it takes to get to 3. So we'll know how many frames it is to go 1 second. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 20, 30, there, change to 3. So it takes 30 steps to go 1 second in this thing, okay? And that's all the information we really need. We figured out that it took 12 frames. We counted out that that's how long it took for it to go 30 feet. It's a 30th, each one of those frames is a 30th of a second, okay? So it took 0.4 seconds for that pitch to travel 30 feet. And so we can calculate that 30 feet over 0.4 seconds is 75 feet per second. And we can convert that to miles per hour if we want to do that. And it turns out that he's pitching at 51 miles per hour, which the kids, of course, are thrilled to find out about.
And figure out, happens to be a twin.
Right.
His whole goal was to be able to pitch faster than his twin brother.
That's right. The most important thing here is 2 students.